Onward and upward to our final story tonight. Let's talk about what's happened at Mars. Mars, of course, one of our nearest neighbors. People have wondered about Mars forever. People used to think, well, maybe it's somewhere there could be liquid water. We saw signs of dark areas coming and going. It wasn't really understood. They thought maybe this is vegetation or water being delivered or something happening. Little did we know it was really dust storms and maybe a few high clouds covering up things, obscuring what we could see down below. But it doesn't mean that it wasn't a great year to send, like Chris said, some spacecraft to Mars. And of course, the Hope orbiter was sent there, and it was sent by the Emirates Mars mission, as you can see there. And it's actually made some interesting discoveries. You can see here, Mars aurorae are kind of difficult to see. All the spacecraft we have are so low and so close to Mars. Previously, they were a little difficult to be able to picture, but this orbiter was able to see these discrete aurorae on Mars. And, it's kind of the bright crackles seen on the night side. Let me see if I can get my laser pointer out here for you. Here we go. It's this stuff over on the night side you're seeing that's the signs of the aurora on Mars, not the bright daylight glow that's over there. So that's a first that we've seen that sort of distribution from so far away. Another mission, of course, the landing of a rover on Mars. It was so exciting. The Chinese rover Zhurong landed, was deployed on May 22nd, 2021. You can see their parachute there and the rover with these great big huge solar panels on it. It is a solar one. They brought a little selfie camera with them. It drove over, dropped off the selfie camera, backed up, and
wow,
cute little rover. I love that little face that it has there. It's sort of pondering the selfie. Although, I don't know, they should have stuck a selfie stick on it. It would have been cute, I think. There's not a whole lot of information coming from this rover. The Chinese have been pretty quiet about it. A few papers have been released just kind of talking about the rocks and analysis, but not much there. It was really off, I think, the friction of the driving over there. So the movement of the wheels they were looking at. But so far, they're pretty silent about the data. They're being rather closed about the science that's coming out of this. But congratulations to them. So that's really the big excitement for Mars. And that was about it this year. So thank you so much. Of course, I'm kidding. Of course, I'm kidding. Right next to Zhurong. Well, in between, Zhurong's in between Viking 2 and, of course, Perseverance, the major landing of NASA's at Mars this year. And we did indeed land. It entered February 18th, 2021. And we're going to show this video of the entry and descent and landing again. We put together a little bit of the animation to fill in some of the areas. We added in to show you what it looks like off to the side. Wonderful job by our video editor, Sarah Vincent, did a really wonderful job with this. So thank you so much. I hope you enjoy this short video about the landing of Perseverance on Mars.
Indicate chute deployed.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance has now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
So that is just craziness. The fact that we saw that sky crane fly away. This is all the steps that had to happen. First comes in, heat shield is protecting it, peak heating. That heat shield gets ejected shortly after that parachute comes out. Radar lock on the ground so you know how far away you are, can start tracking. And then literally the back shell gets ejected and you go into free fall until they light those rocket engines and the power descent. The radar is seeing the ground. They're getting a lock on the ground. They had imagery from orbit that they had programmed into the cameras that it was recognizing features on the ground as it was flying over to be able to figure out, am I in the right spot? Then it cuts away, literally lands, lowers it on cables. The rover's there and that sky crane is cut away and we saw it fly off and it crashes off in the distance. So a completely amazing landing, and it touched down just beautifully right in the middle of Jezero crater. Now that parachute, you might remember that sort of is weird looking. Now they do that partially to be able to track the motion of it, see how it's deployed, be able to see what's happening to the parachute, but also, well, JPL, they're a little bit of tricksters. Remember our Curiosity rover, they put JPL into the wheels. It would roll and in Morse code would write JPL. So they literally tagged the surface of Mars in their rover tracks. Now the dust is or the winds are gonna blow that away. It's not permanent or anything. This time they decided to print it on the parachute. And indeed, you can go in and figure out the code to see what is all those patterns. Well, it was a code and it spells out dare mighty things with a little bit of a latitude and longitude there. I'll let you go look that up and maybe you'll figure out what that location. It'll be a little bit fun for you. So type that into Google and see what you find out on maps or one of them. Now the landing site, you can see the Phoenix InSight landing ellipse that goes off of the screen actually here. Very, very large, not a lot of control over where we're going to land it, but pretty good overall. Curiosity smaller, about 15 miles by 12 miles. Well, the Perseverance landing site was much smaller. They were targeting in an area that was only 4.8 miles by 4.1 miles. Well, how'd they do? Let's take a look here. They are almost in the very center of that small circle, right in the area where they wanted to be. It was a spectacular landing, spectacularly precise landing of that rover. It was even pictured from the Mars Reconnaissance Orbiter. I saw a picture of it. It was a little tiny parachute down in there, but they did catch it coming down. Now, interesting enough, some of these features that Perseverance is seeing are being named after Navajo names to celebrate the Navajo language and the contributions to JPL in space and science. That rock right there is called Maz, which of course is the Navajo word for Mars. See here a close-up of it, and there were measurements taken of it. And this is the rock Yigo, which means diligent. And I'll show you the region that these were taken from in just a minute or two, and some of the information we're learning from it. Now, the path that it's taking, the rover first landed here at Octavia E. Butler Landing Site, and I recommend science fiction books by Octavia E. Butler. Check it out. Great name for the landing site. And then the rover decided to go sort of south and wrap around over here to this Saita North and South site. I don't know how to pronounce that, by the way. I'm sorry if I'm causing problems there, but that was a reason to go investigate some of the terrain. They thought this is an opportunity before we sweep back around and head over to the Three Forks, which wasn't that a inn or a tavern in Lord of the Rings, the Three Forks Tavern?
It should be.
So anyway, no, it wasn't, of course. But of course, the Perseverance, the rover, didn't go alone. It brought a helicopter with it. Indeed, Ingenuity, the little helicopter, was brought to the surface. And they thought, well, we'll fly a couple of times. It is a test mission. It's a lot like the Pathfinder mission that taught us how to rove on Mars. Well, this Pathfinder mission for Ingenuity is going to teach us how to fly a helicopter. They thought, well, we'll get 2-3 flights off, maybe 4. It'll probably break. It could crash, but we'll learn how to fly on Mars. Well, we have flown now 18 times. It has gone back and forth. It's getting good data. They're learning more and more how to control it. It's actually doing some scouting for Perseverance to kind of see where Perseverance could go. It's turning out to be a very handy tool to have with us, and we've learned a lot. So we put together a little video to help you enjoy what Ingenuity's been doing, as my other cat's coming to visit now. So let's take a look at this video that we put together on Ingenuity and enjoy the music as well. So we're not just flying around for fun, playing with our helicopter there on Mars, although that was actual footage. That footage was taken by Perseverance. So you are watching a helicopter with, anyway, it just blows my mind that JPL pulls this stuff off and it works. It gets there, and we're flying two vehicles. Well, we're flying a vehicle and we're roving a vehicle right next to each other. Super, super cool stuff. Well, the science coming from Perseverance is pretty darn cool too. The Sherlock ultraviolet spectrometer has, along with the Pixel X-ray spectrometer, have been used to piece together what's going on with those rocks under the rover's wheels. You can see here this is Sherlock here, the camera, and a laboratory image of the sorts of cool glows that you get out of this when you're seeing organics and things like that it's looking for. Indeed, Sherlock's looking for some organics. We thought there would be organics in Jezero Crater. This is of course, an image from orbit showing those greens that we're looking for. And we thought, well, let's go look for them in this crater and see if the water that washed through there interacted with the rocks and maybe left these organics. Now, organics don't mean life necessarily, but they're the molecules and elements that life needs, and the sort of stuff that you'd need if maybe there were little organisms there in the past. So very exciting indeed. Those instruments were indeed saying, yeah, there are organics there. Sherlock is seeing evidence that water has interacted with this material and that organics are there. Now, the Pixel and RIMFAX has also been used. The X-ray spectrometer and the subsurface radar have been making some neat discoveries as well. This is Pixel here, and they were able to look at rock nicknamed Brack, and they were wondering what it was made of because it seemed to have a lot of large crystals. Those crystals did indeed turn out to be olivine, and this rock with these crossed crystals we think formed in underground. It was a magma that cooled and came together, and those crystals form under certain conditions. So the geologists are going to be able to look at these rocks and what these instruments are measuring and tell us. Maybe I should show you the actual region. True color above and enhanced color to make it look more like it would look on Earth down below. And they were wondering, are these rocks volcanic? Are these rocks sedimentary? How did they get there? Well, it turns out they were volcanic. Like I said, it was magma under Mars's surface that cooled slowly enough to let these crystals come together. Then water interacted with it over and over and over again. So it's the combination of this magma and these crystals and the waters. So this is going to be a very, very interesting story as we put together all these measurements that Perseverance is making. But so far we've learned that the floor it's driving on, it's not sedimentary, it's volcanic. So to get to those deposits that are sedimentary, that might have life in them, maybe buried into the layers, it's going to have to drive somewhere else or look at some other sorts of deposits. But we are learning about Jezero Crater, and we need to do that if we're going to understand the other deposits. So moving along here, I mentioned that RIMFAX instrument. Well, it's actually a downward penetrating radar, a radar that penetrates the ground. So you can look for rocks that are denser, you can look for sands that are less dense, dusty areas, Well, what is it seeing as it drives along? You can see up above is the top view looking down, and it drove along this path, kind of going over these interesting ridges, interesting features. Well, down below is penetrating down into the ground, and you can line up some of the features here. You can see T3, this set of hills. They must be harder, denser, more difficult to erode. They penetrate down into the ground. They continue down into the ground below. Also, notice these sort of slanted features coming up out. I'm wondering, it seems to me those are probably created from the impact itself that tilted the layers when the basin itself was formed. But this ground penetrating radar, completely new. It's showing us details about how deeply these hills penetrate. Very, very interesting to see these erosion resistant hills going deep into the ground. Now, the path we're going to be taking here, like I said, we've been driving all around over in this region. Well, the sediments we're interested in are really over here by Three Forks. So we are looking forward to moving off in another direction in the future. So we're going to go explore the rest of this big basin and see how that water interacted and see if maybe any signs of life were left behind. Well, we've been looking already. You need to study the rocks as you move around, and Perseverance has the ability to take samples. It drills in, pulls out a core, puts it in a canister, seals it up, stores it, and moves on. And then later, we need to figure out a way to analyze those. I'm not exactly sure how long we're going to have to wait for this, but some of the instruments that we analyze rocks with are literally the size, and by the way, as I'm talking about things, I guess I should show them to you. These are the samples Perseverance has taken already. So you can see these rocks are different color, different textures. They look different. Now the geologists will look at these and say, oh, I think this might be a rock that could contain certain amounts of information. And then you need a different rock to see different things. You analyze all these different structures and you put together the whole story of what's happening in the crater. Now, to do this, you need instruments that are big, much, much bigger than you can bring with you on a rover to Mars. So the idea is we will return, that we will go back to Mars and pick these up later and return them to Earth. So that's all coming in the future. And I don't think it's coming in 2022, just so you know. It's not coming in 2023, I don't think, but you can see here, indeed, there is some initial drawings of what this thing might look like. It's going to come down and land. It'll have a rover that'll be able to go over and grab them. Maybe they'll have some sort of helicopter or something that'll grab them. I kind of doubt it, but the way Ingenuity is flying, it makes me wonder. Now, I've got big questions about this. I'm sure you do too. Why samples? How long do we have to wait? Is it going to be 2030s? Well, we're exceptionally lucky. Next month at All Space Considered, we have Dr. Matt Gollenbeck back with us to talk all about Mars. And I'm going to ask him these questions. What's the sample return mission going to be like? Are they going to just leave these, test tubes sealed on the ground of Mars, and do they got to go drive and get them from a bunch of different places? Or are they going to find one nice place that has maybe a little bit of shade and protection from the dust devils? I don't know. But anyway, so we're super happy to have Matt come join us next month at All Space Considered. And I'm sure hoping all of you come join us as well